All right, this recording is about matrices. It's really an introduction to what a matrix is. A matrix is a rectangular array of terms with m rows and n columns. So it's kind of a way that we show a set of numbers. And we'll get more into how we get matrices and how we find matrices. Matrices is the plural of matrix. But let's just talk about what like a matrix looks like. We use kind of these brackets to show a matrix, and matrices and a matrix can be a lot of different sizes, and we'll talk about how we get our sizes. The size comes from the rows and the columns. So I'm going to make up a matrix here, 5, 7, 2, -1, 0, 14. So when we have like a number like a 14, we just put it right next to each other. So this matrix, if I asked you, okay, what size of a matrix is it? You give an answer that it's the rows by the columns. So you'd want to say, well, this matrix has 2 rows, excuse me, and 3 columns. So this would be a 2 by 3 matrix, and we usually put it in the lower right-hand corner when we say what's the size of a matrix. We can have another matrix here. I'm going to make kind of a different shape matrix. I might say 1, 4, 6, or 3, excuse me, -14, 0, 9, 3, 7, -4. Okay, this matrix is a 3 by 3 matrix. There are 3 rows and then 3 columns. So you can kind of see each matrix has a little bit different. When they're talking about a matrix, like let's say I'm going back here to my first matrix, and I want to say, okay, how do I indicate to someone where a term is? So if I want to say, oh, I want to indicate here this first term, this term of 5, how do I indicate where it is? Well, I could say it's in the first row in the upper in the left-hand corner. But what's nice is they kind of have given us another way that we can show exactly where something is. All right, and that's by saying, okay, this is our matrix A, and then we're going to say it's in the first row in the first position. So this is A11, okay? The 7, so let's say now we're going to talk about the 7. The 7 is in A12. It's in the first row in the second position, okay? The 2 over there is in A13. The -1 is in A21. The 0 is in A22. And the 14 is in A23. This is just a notation, and it's really something you might need to know when you're working in your book. Let's look at some other types of problems. Let's talk about adding and subtracting matrices. What you want to do is you're just going to add in the same position, all right? So you're going to add the values in the same position. So we just talked about how sometimes we have the position A11, and we're going to add it to the B11. And then that's going to be in our new first position. Then you're going to have A12, and we're adding it to B12. We're going to have A13, and we're adding it to B13. All right, and it kind of goes from there. So if this is my A matrix, and this is my B matrix, this is how I'm going to add it. Let's look at this. So I'm going to look here at my 3, and then I'm going to add it to the corresponding spot here. So in the first one, for my answer, I'm going to have 3 plus 2. Okay. And 3 plus 2, we can even replace it. Let's replace it right now with a 5. Okay. Now we're going to move over and say, okay, we want to know now the middle term. So now it's -1 plus 4. We're going to replace -1 plus 4 with a 3. Now we're going to look at the 0 and the 7. 0 plus 7 is 7. Let's look at the 5 plus the 0. 5 plus 0 is 5. Here we go again. We're going to move over. We're going to go 16 plus -6 is 10. And then now we're going to look at 4 and a negative 3 is 1. So that's our answer matrix of A plus B. And we just took each term in the exact same position and added it together. So we have our matrix. So we took here a 2 by 3 matrix. We added it to a 2 by 3 matrix, and we got a 2 by 3 matrix as an answer. And that's the way addition and subtraction goes. You have to have identical shaped matrices, and your answer is going to be that same shape. Now let's look at what we call scalar multiplication. It's where we multiply each and every term by a value. So here we have our value k. And really what we're doing is we're taking this k and we're multiplying it by the 1. We're taking the k and multiplying it by the 4, the negative 5, the 0. So let's, instead of a k, let's look at an example here. And let's take this matrix here, but let's multiply it by 4. Oh, I don't like green. Okay. 1, 4, negative 5, 0, 2, 10. So we're multiplying it here by our 4. So first I'm saying to myself, oops, sorry. Okay. So first I'm saying to myself, okay, here's my 4. I'm going to take my 4 and multiply it by the 1. Okay? So 4 times 1 is 4. Now I'm going to take my 4 and I'm going to multiply it by the 4. 4 times 4 is 16. Take my 4 and multiply it here times the negative 5. 4 times negative 5, I got to make this a little bigger. 4 times negative 5 here is negative 20. 4 times the 0 is 0. 4 times the 2 is 8. 4 times the 10 is 40. So that's what scalar, multiplication is here, is we were able to multiply each one of those by a single term. And we're going to be talking here about how to use a calculator in the next video. And actually this calculator will do all of this same addition for you. So here if we have A minus D, we're just going to take the individual terms minus each other. So I'm going to have you guys pause the video now, and I'm going to have you work on these 4 problems. Go ahead and just hit pause. So here as those same problems worked out, the important thing to recognize with the first problem, the A minus the D here, is that we're subtracting. And so you have to remember that you're taking minus a negative 3 here. You're taking minus 4, minus 7, minus 1. A plus B is not possible. A is a 2 by 2 matrix, and B is a 3 by 2 matrix. So you cannot take a 2 by 2 and add it to a 3 by 2. So they weren't the same dimensions. C minus B was pretty straightforward, but it was really about writing it in the right order. So having it written out does help. 2B plus C, we had to first do scalar multiplication on B and then do the addition. So you do have to do the multiplication before you can do the addition. So we had to take 2 times 2 is 4, plus the 2, and that's how we got the 6. 2 times 0 is 0, plus the 1, and that's how we got 1. So those are the answers there.